Okay, Algebra 2 students, today's the day. This is the first video for section 2.6, the quadratic formula, the most used formula in Algebra 2. Well, arguably. How can you use the quadratic formula to solve quadratic equations or predict the nature of solutions? We have the discriminant and the quadratic formula we're going to learn about, and in the end you're going to be able to solve quadratic equations using the quadratic formula. First example is solving quadratic equations. We've done it with completing the square and some other methods. Here we have 3x squared minus 4x minus 9 equals 0. Here's the quadratic formula to memorize. We know this is A, 3 is A, negative 4 is B, negative 9 is C, and then you just plug it into that formula. I make it sound easy, but it's not that easy when you're first starting out. So they plugged them all in, then they evaluated them, and here's their final answer. Now let's see to go through this. 16 squared minus 4 times 3 is 12, and then there's the negative 9 there, so negative 9 and the negative make it a positive. So it comes out to 124 in the square root. And then simplifying a square root, you may need some practice with that. 124 is 4 times 31, so the square root of 4 is 2, so that's how it came out. 2 square roots of 31. So we have 4 plus or minus 2 square roots of 31, all divided by 6. And because the 4, the 2, and the 6 are outside the square root, and they're all divisible by 2, you can divide the 4 by 2, the 2 by 2 to get 1, and the 6 by 2 to get 3. So the solutions are, this is an acceptable way to write the answer, 2 plus or minus the square root of 31 over 3, but if you want to think of them as two different values, you can have the plus and the minus. Alright, I thought they were going to go a little slower. I apologize for going so fast through it, but we'll do some examples. Same thing, how can you use the quadratic formula? Well, the coefficient of x squared is 1. The coefficient of x is negative 9, so that's b, and c is 27. So then they start plugging those values in and solving, but something different is going to happen in this problem. Negative 9 squared is 81, minus 4 times 1 times 27. 4 times 27 is like 108, but it's a minus 108. And I did that wrong. Oh well. Oh, 81 minus 108. And it comes out to negative 27. Now if you recall, the square root of a negative, that's where we have to bring in the I. It's a complex numbers. So that's why they solved it like this. I square roots of 27, because it's got the negative, so you just take the I out. Now 27 also has a perfect square in it. 27 is 9 times 3, and 9 is a perfect square, so you can take a 3 out. So they did that. And now let's look. 9, 3, and 2 are all outside the square root, but they're not all divisible by the same number. Like if this were a 3, then we could reduce them all by 3. Or if it was a 6, or any multiple of 3, actually. It says simplify, so I'm wondering if they're going to break it into two parts. Let's see. Nope, they didn't. They just kept, because this is an acceptable way. That plus minus means there's two answers, and here are the two answers. Okay, not sure if that was enough examples for you, but here we go. One for you to try, or two for you to try. Plug those in, or if you want, let me go to my screen here. Here's the quadratic formula and the problem. Go ahead, click pause, give it a shot, come back when you're ready. All right. First it's solved for 0, so now I know this is A, this is B, this is C, then I'm going to plug it into this. The opposite of B, negative 6, plus or minus. Let's see if this one ends up being a negative or not. We have b squared. B is 6, so if you don't mind, I'm just going to write 36. Save some time. Minus 4 times a, which is 2. I probably should have done that right off. Times c, which is 3. I mean, it is better, especially if I'm giving you your teacher's giving you partial credit, to write them all out before you try to do stuff in your head. 2 times a. A is 2, so 2 times a is 4. All right, let's see what we get for this mess. 3 times 2 is 6. 6 times 4 is 24. And there's only one negative, so it's a minus 24. 36 minus 24 is 12. So I have minus 6 plus or minus square root of 12, which has a perfect square in it, but I'm going to try to be patient and deal with it in a little bit. A common mistake I've seen students do is they say, oh, they're all divisible by 2, and you divide them all by 2, but this is in the square root. We have to take it out of the square root if we're going to be able to reduce it. 12 is 4 times 3, and 4 is a perfect square, and the square root of 4 is 2. So now I have plus or minus 2 square roots of 3, because 12 was 4 times 3, and the square root of 4 is 2. This is all divisible by 4. And that reduces. The 2, the 6, and the 4 can all be reduced by 2. And I'm just going to go right to their answer now that I got so close to the end. And I was running out of space. Oh, they wrote it different this time. So you can write it this way. You can break it, the plus minus, and keep the fraction. Let's go back to this. Negative 6 over 4, you can reduce it to 3 halves, negative 3 halves. And then you can have the 4 over here for the 2 over 4, which comes out to 1 half. See how they wrote it? 1 half. So that's another way of writing it. Okay, try this one. Click pause. I am not going to go through this one to save time. Just going to go to the answers. Unless it ends up being something sneaky, then maybe I'll go over it. Oh, the I showed up. So hopefully when you are solving it, you had a negative, see if I can do this in my head. 2 times 2 is 4. So you ended up with a negative square root of negative 20. Maybe you ended up with a square root of negative 20. Maybe not. Oh well. Let's see what your teacher could assign to you. A lot of problems. Love the quadratic formula. 16 through 21, 38, 10 and 15, 13 and 39. That's it for this video. Have a great day.